all. This is N7GES with the NCARC TechNet. I'll start by taking a few check-ins, and then we'll come back and talk over topics or whatever. Who's interested in attending this evening? N7GES.
This is Kilo Echo Zero, Lima Charlie Kilo, KE0LCK, another mic from Windsor.
Lima Alpha Papa Romeo Bravo in Loveland.
Good evening, Kevin and Nanette. This is Whiskey Zero, Delta Delta Zulu, Dave and Greeley.
Kilo Zero Echo Victor, Eric near car.
Good evening, Kevin. This is Kilo Zero Alpha Bravo Kilo, Alec and Greeley.
Okay, let's take a break there and catch a couple of these, and I know I've missed a couple at least. K0ABK, good evening. K0EV, W0DDZ, K0PRB, and K0LAO, and KE0LCK. There was at least one double, who did I miss, or who else would like to check in?
KE0OXB, Scott. Kilo Foxtrot Zero, Colorado Boy, Mike, Fort Collins.
Whiskey Zero, Romeo Delta Charlie, Rob, Owl Canyon.
This is Kilo Echo Zero Quebec Foxtrot Bravo, Coleman from Fort Collins. Excuse me.
Okay, let's see. We got a bunch here. KE0QFB, Coleman, I believe. Have I got that all correct?
Affirmative.
Okay, have we visited before, or are you new on this repeater?
I'm new. I did my first contact here last week. I got my license the week before that. It's on a Baofeng UV5R.
Okay, well, congratulations, and thanks for coming by, and don't hesitate to speak up if you've got questions or whatever. So we'll come back around here. W0RDC, welcome, Rob. KF0CB, good evening, Mike. KE0OXV, good evening, Scott. Anybody else that wants to check in so far?
Evening, Kevin. This is Kilo Zero Delta Bravo Echo, Debbie in Fort Collins.
Well, good evening, Debbie. And I'm hoping that means that my brain's gone dead tonight. EMP hopefully is not too far away either there, but how's things going for you?
Things are great right with us, and yes, N0EMP is here and listening. He was going to wait until the board check-in, but you can consider him checked in now.
Okay. Yeah, I wasn't even thinking of doing board check-ins, but it's not a bad idea. Hadn't planned that far. Anyway, thank you, folks, for checking in. We got a good bunch here. I failed to ask if anybody had questions that they wanted to raise when they were checking in, so we'll just have to go back around to that. But before we do that, let's just see if there's anybody else that wants to check in before we get started here.
KG0HM.
Good evening, Lauren, KG0HM. Glad to have you in here this evening. Anybody else? Okay, very good. This is N7GES. So, since I failed to ask if anybody had questions or announcements or anything they wanted to make, we'll just take a quick recheck. Anybody have a question for the net? Anything they want to bring up and get some input about here?
RDC.
RDC, go ahead.
Thank you, Kevin. Yeah, I just wanted to put a big thank you shout out there to KD0USB Mike. He's one heck of a diesel mechanic. He came out here and got my truck up and running. So, and I also want to thank their Mark W2MIC for getting us hooked up. So, and that's all I needed to say there. So, thank you guys. It was great. W0RDC.
Well, there you go. Let's see. Mark came up with the acronym. Oh dear, what was it? Well, my brain is really out tonight. I apologize, folks. Anyway, for the assistance that you can get through ham radio. Well, I'm glad you got that truck going again there, Rob. That's excellent. Okay. Anybody else have questions for the net or wondering about something that they're new to the radio or new to a particular band or to the repeater or anything else that you'd like to ask? This is TechNet, so nothing is, for the most part, nothing is out of order here.
MIC.
MIC, good evening, Mark.
Whiskey 2, Mike, India, Charlie, Mark, in Loveland. Ham Emergency Assistance Program, HEAP.
Thank you very much. I knew there was an acronym and I couldn't come up with it. Well, anyway, that's great. And you've obviously already made several people very happy there, Mark. So thanks for being a part of that there. And I know you've been a part of that kind of thing for a long, long time, even before we had an acronym for it. So there you go. All right. Any questions for the net from anybody?
LCK?
LCK, go ahead.
Yeah, this is KE0LCK. I just wanted to thank the people that came up Saturday to visit us for the HF demonstration and to apologize to a couple of the people had set up a digital data demonstration and I worked on it at home, and naturally I take it all apart, bring it up there and put it all back together, and it doesn't work. So I spent a good half hour or so trying to get things working. That was after the one gentleman pointed out, hey, is that your antenna lead you're supposed to hook up? But nonetheless, I was able to talk to a number of people, and I appreciate that, but I missed names. I had my head down. But anyhow, I appreciate the people that came up and at least had the opportunity to look at some of the things we had there. Back to Ned.
Okay. So did you have an antenna disconnected?
I had the antenna hooked up and the cable run in, and I tied it to the leg of the desk just to make sure if somebody happened to trip over it, they wouldn't pull my radio down. And I hooked all the cables up to the tuner, into the separate sound modem card and the computer, and I got everything hooked up, but I forgot to take the rest of the connection for the antenna that I tied to the leg and actually put it into the radio.
Oh my. Well, you know, how many times have we done that? Or almost done that anyway. So, well, I hope everything was okay after the fact, and we all learn those lessons even after we've been into it for many years. So, how many folks did you end up having? I heard something like 20 folks or so. Do you happen to have a count for this anyway?
That's LCK. I don't know how many people there was. I know at the beginning we were wondering, is anybody going to come? And then I was having my technical issues, and people were sitting down next to me and asking me, well, what are you trying to do, and this and that. And I'm trying to get it going and explain it at the same time. And unfortunately, I had a few printouts that I had done ahead of time of what it should be looking like, and the whisper sheets and stuff like that. So, but yeah, at one point I remember looking up, and it was like 3 hours later, and people were still comping around. So it was a pretty good crowd. I just don't know the numbers.
Okay. Well, that's excellent. I'm glad to hear that there was interest. And yeah, trying to explain while you're trying to work is very difficult. So my hat off to you for that, because that's a toughie. But you had people that were interested, it sounds like, and were sticking around and not necessarily running away because things didn't work. So that's great. That is a part of radio. Well, I'm glad to hear that. I'd heard there was a pretty good crowd, at least at one point, so glad to hear that. And so let's see. This is N7GES. Somebody asked a question earlier, toward the end of last week, midweek or something or other, which I was attempting to answer in a very unprepared state, and somebody else took over. It was kind of one of those customer service deals. Do you have all the info? And me starting out with not necessarily knowing all the info in the first place, but then realizing that I didn't quite have the question straight. And it led me to think maybe we should discuss it just a bit more here for better clarification. We had a guy setting up an antenna, and he was asking about radials and or all I can say is tiger tail, but the technical word I can't come up with right now. But there was confusion on an image plane. There was a confusion on which was needed for what purposes. That was, I think, talked through pretty thoroughly with JR, but I just wonder if anybody'd like to expand on that a little bit. When do we use one, or when do we use the other? Or do we need both at certain points in times? Well, I know we have some technical folks that would be very easily able to do this. Does anybody want to take a stab at it, and then we can get corrections from folks that are better prepared to answer it? A wrong answer is sometimes a great way to learn about the right answer. But I'll put it forth at some point, but I want to give everybody else a chance first here.
N0EMP.
Yeah, go ahead, EMP.
Yeah, I was part of that original conversation, I think, if it's the conversation I'm thinking of. And it also segues into a ham I've been trying to help with an antenna installation. And we're seeing some interesting things I wanted to bring up anyway. So this is a good segue. And I'm glad Mark, W2MIC, is here because he may offer some clarification on some of what I say. But people use the terms image plane and ground plane and radials and counterpoise. They use these things interchangeably. And there are some differences there. So if you're feeding a power into an antenna, and let's just use a quarter wave element, you have to have something for it to work against. So if you have your coax and you have your shield and you have your center conductor, and your center conductor is connected to your quarter wave element, that shield has to be working against something. And in one of the most basic antennas is a dipole, and that shield is connected to the other half of the dipole, and the two halves of the dipole are working against each other. So you have one quarter wave element connected to the center conductor, and then you have that shield connected to the other quarter wave length element. That's the other half of the dipole. They're working against each other. If you have a quarter wave vertical stuck on the roof of your car, and your coax center conductor is connected to that quarter wave vertical, the shield is connected to the base of that antenna mount and connected to the body of the car. And if you're working at a frequency that's such that the dimensions of the vehicle are less than a quarter or more than a quarter wave, like 10 meters or 6 meters or 2 meters or 440, the body of the car acts as your ground plane or your counterpoise, whatever you want to call it. A lot of mast-mounted antennas, such as, again we're talking of vertical, such as you see with a lot of the old Citizens Band antennas for a base station. You have a vertical section, which again is fed by the center conductor, and then you have these quarter wave length long rods sticking out the sides, and that acts as a counterpoise, and the shield is connected to those. But because they are sticking out to the side, you have a vertical element, and these things are sticking out at 90 degrees to that element. They are sticking out radially. The term radial means basically sticking out to the side. And they might stick straight out, or they might slope down to give you a 50 ohm match.
But either way, that's still a counterpoise or a ground plane or an image plane, but those are called radials because they stick out radially from that center vertical. Mark, how am I doing so far? N0 EMP.
W0LEV.
Yeah, let's take Mark, and then I'll come back to you there, Dave. Go ahead, Mark.
W2MIC, I concur with what Greg has said so far. I have a few additions. Let's let Dave go.
Thanks, Mark. One nitpick. Get the button down here. The correct term for the plane beneath the quarter-wave vertical is an image plane, named after the outcome of Mr. Maxwell. In reality, that plane does not participate in radiation. Only the quarter-wave vertical orthogonal to that plane radiates, unlike the dipole. Mr. Maxwell dictates that at the surface of that plane, and we won't go into resistance and skin depth, fields cancel. The plane works against the quarter-wave vertical, not so much the coax. It really shouldn't work against the coax. Ground plane, what is that? There really is, in RF, no ground plane. It's an image plane. Basically, Mr. Maxwell dictates that. I think that's the only nitpick. Other than that, I think you're just peachy fine there, Greg. W0LEV.
Okay, yes, those are all good points. And to continue here, if you're pumping power into an antenna element, such as a quarter wave or whatever, you have your center conductor of your coax, and it's pumping power into some type of antenna element that you plan to be a radiator, you're going to have some kind of counterpoise, whether you meant to or not. If you build something that's intended to be a counterpoise, such as the other half of a dipole, or radials, or a car body, that's great. If you don't have something that you deliberately built to serve as the counterpoise or the other half of the antenna, the outside of your coax is going to serve that purpose, or a metal mast if you have your antenna mounted to a metal mast, or some nearby conductor. And that's where you hear about things like RF in the shack. Normally, when RF is going through coax and it's terminated in a balanced load, you have RF current flowing on the outside of the inner conductor and the inside of the outer conductor or shield. But if you don't have a balanced termination, such as a counterpoise or radials or something, you're going to have RF current coming back down the outside of the coax, and it's going to keep going all the way back into your shack and get into electronics and your speakers for your computer and all sorts of other stuff like that. So what this all led up to is I was helping a ham who is interested in portable operation, backpacking, QRP, and also setting up a low-profile antenna at his house. And he bought an end-fit antenna. It happens to be an MFJ, but that's probably not relevant. It's supposed to work from 40 meters on up, and he's about 6 miles away from me, and he can only run 5 watts because he's got a Yaesu 817. Had his antenna up at 15 feet approximately, and I could not hear him 6 miles away. He could hear me just fine. He could copy other stations, and he was trying to run PSK 31. I could not hear him at all. Let this reset. And eventually, after we tried a lot of other things, including putting in power meters and stuff to make sure he was actually putting 5 watts out to the antenna, we strung up a simple 40-meter dipole, just 2 pieces of wire, trying to eliminate all the variables we could. Put up a simple 40-meter dipole, same location, same height, same orientation that the other antenna was at, and came back here, and he was booming in on PSK 31. It was a huge difference. So then we went back, and he put his NFED back up, and he added a counterpoise to it. We were hoping that would help. It did not. Still no good. No luck getting out on the NFED antenna. Although he did make some whisper contacts to other states. I couldn't see him here 6 miles away. We tried 40 meters and 20 meters. No luck at all, even with a counterpoise. Dipole worked just fine. So I guess the takeaway there is if you're having antenna problems and nothing seems to work, try putting up just a basic standard reference type antenna and start from there and work your way up. And 0 EMP.
Okay, this is N7GES. That was a lot of info, and that may generate some questions. I'm kind of going to start with one, though, here. I take it you haven't really decided what the problem with the NFED antenna was as far, and I take it that it's more, the problem was that it wasn't, not that it wasn't getting out at all, but that it wasn't getting in close in. Am I right on that, or was it actually not working in general?
Well, that antenna, that specific antenna, has good ratings on EHAM, so people have gotten it to work, and it should be working well, in theory, as an NVIS antenna on 40 meters. It's about 15 feet off the ground. SWRs look good. It receives just fine. He's receiving PSK from all over the country. After he added the counterpoise, he got some whisper contacts out to like Kentucky or something, I think it was. So he's getting out to some extent somehow, but I don't know if something strange has happened with his pattern where it's not radiating up, so it's not acting as an NVIS antenna even though it's at the right height for one, or if, because he's only running 5 watts, I don't know if there's a lot of loss in his coax and that matching transformer, and if he's only radiating, 500 milliwatts of ERP, I don't know what's happening. The antenna appears to be intact. Nothing's broken on it. It's brand new. Tunes up the way it's supposed to and receives just fine. He can hear me. I'm running 5 watts here, and he can hear me just fine, but he can't get out on it with 5 watts. Whereas a dipole, same length, same height, same orientation, same location, just comes booming out. So we still don't know what's going on with him. But I don't have a lot of experience with NFED antennas. Other people have had good results, so I just don't know what's going on there. And 0 EMP.
And suggestion?
Suggestion, go ahead.
W0LEV here. Just a suggestion, being MFJ, I would check both sides of the matching transformer, such as it is. An NFED half-wave antenna is going to present a very high impedance, being a half-wave. That's why we take a half-wave, chop it in half, and feed it in the center, where there's a high current point rather than a high voltage point. Really, Greg, I check, feed one side of the thing, terminate the other side with the resistor, and see what it looks like. I don't personally trust MFJ in that respect. I know Phil, PRB, runs a half-wave NFED with good success. You might compare with him. But another comment, the long wire or half-wave antenna fed directly with coax with no decoupling stub or anything is just a license to light up the ham shack. RF in the shack is usually due to not providing the whole antenna. I explained it in the RF in the shack program that I know recently I've given out in Greeley. Yeah, enough. W0LED.
Yeah, Dave, my actual recommendation based on the bands that he wants to run and the modes he wants to run and the location of his shack versus the layout of his property versus where the trees are that he's going to use for antenna supports, I'd recommended a 40-meter off-center fed dipole, which he's gathering stuff for right now. So that'll work with his layout and what he's trying to do, and I've had a lot of good luck with those myself, so it's something I'm more familiar with, and it's got something to work against there besides the coax, so I think that's going to serve him well, and 0 EMP.
Yeah, what I've used out camping, I don't run HF while driving, but I do camping from the vehicle. I typically have, it's about a 60-foot hunk of wire that I will tie a rock on the end of, pitch that up in a tree, and wherever it ends up, it plugs into an antenna matching network. I use a MFJ Versatuner 2, which has been repaired. It didn't come very well from the factory, and it's not too robust. But that, against the Jeep, that has worked out very well. One day up in the Snowies, I compared that on 80 meters, 75, against the 75-meter high-power Hustler radiator that was mounted on a Jeep. And I don't believe in S-meter calibrations. I've checked many, and none of them are worth anything. But consensus of 4 other people from the Snowies out into the plains of Colorado, typically 12 to 15 dB difference, in favor of the random wire pitched up into the tree, matched with antenna matching network. W0LED.
LCK?
Just about doubled with whoever that was. Come again?
LCK?
Yeah, go ahead, sir.
Yeah, it's KE0LCK. Yeah, Greg, I have a multi-band NFED wire that's supposed to be 80 through 10, and it has a trap in it about, I don't know, 10, 15 feet from the end. But with the 817 that I have and that antenna, I can crank over into Europe and Asia frequently. So I'm wondering, it might be a bad trap.
Yeah, his particular one is 40 meters, so there's no trap. It's about a half wavelength long at 40 meters with no trap, so it does not work 80, and so that's not the issue there. But it could be the transformer. I personally haven't checked that out yet. Dave had a good point about putting a known non-reactive resistance on it, and then checking, sweeping it with an S meter or SWR bridge. I think that's what I'll be doing next. N0 EMP.
Okay, N7GES. Well, this is interesting because there's a lot of different stuff here going on, and covered a lot of different details. Anybody else have questions on all of this? Either less or more technical.
KG0HM.
Go ahead, Lauren.
Yeah, I made a Marconi inverted L antenna, and I got it from online from someplace in England, some guy. And then I had to run all these counterpoise around, and that didn't work out too well. So I bought a artificial ground, but I never could figure out how to use that. Has anybody had any experience with that?
I have not myself, but basically what that does is presents in a lumped equivalent non-radiative manner the image plane. It's all locked up in supposedly non-dissipative lumped elements, L's and C's, and it does not radiate, but it effectively supplies the rest of the antenna. I'm particularly not a fan of it.
Well, I certainly are not. Of course, it was homemade. Who knows how I blew it, but I did get some reception. But but I got this artificial ground. I'll have to figure out how to use it sometime.
Okay, so N7GES with the TechNet. So this artificial ground, I take it, is like some sort of a network of components of some sort that are supposed to simulate that I'm not doing well with words this evening. Anyway, Dave, can you give me a little, maybe more basic description of what that probably is?
Yeah, it's a MFJ box.
Well, I hate to use my favorite term here, but I think it applies, that term is snake oil. It's MFJ. I have criticized them a number of times for similar acts of self-praise. It just consists of inductors and capacitors to simulate what otherwise is missing, that is the other half of the antenna. And of course, it doesn't do it very well.
Yeah, I can verify that.
So the one thing that I'm sort of picking up here and Greg or anybody can correct me if I'm wrong. The NFED antenna is always going to be a more complicated project to make work, probably. Was there a reason he chose it over a dipole? Since he was able to put up a dipole and make it work fine that way, was there a reason he didn't go that way in the first place?
Yeah, he's interested in backpacking and hiking and being able to do QRP from the field while he's hiking, and that NFED looked like something that would be easy to put up in the field because he would just need one support for the far end, string it up and go. He's finding that it's not a very efficient antenna, though.
Okay, and you did mention that now that you've brought it back to my memory. So, okay, and that makes sense. And you can't blame people for trying things. And I know some people have made long wires work, but there's probably a lot more trickiness involved there. Okay, this is N7GES with the TechNet. Any other questions, either along this line or in other directions here?
This is November 0, Whiskey India, Quebec, just checking in.
Good evening, Kerry. Glad to have you. Any comment on image planes versus counterpoise versus ground plane? Any of those terms bring anything to your mind?
Yes, once more.
I'm sorry, I was actually speaking to Kerry, but whoever that was, let me get Kerry's input and then we'll come back. I'm not sure who that was.
Well, the efficiency of the image plane, or the other half of the dipole, is simply because it's made of pretty good conductive material. The artificial ground is just made to take the place of such things. Now, you can make a roll-up image plane for a long wire that was just a patch, maybe 3 or 4 feet square or something. Like I said, you can make it out of something that's conductive and will roll up and take that with you, but that's about the best guess I can make, so back to net.
Okay, very good. Did we have somebody else with a comment?
Yeah, that was LEV again. The only correct thing is an image plane, the correct terminology. For instance, the space station certainly does not need to be connected to ground to get RF energy up there and back to Earth. The Krebs Nebula out there in deep space does not need ground to fill space with copious amounts of RF. Ground is a misnomer. Return. RF fields need a lost its battery. Another HT here. That's what the image plane provides. certainly the metal conducting surface of the space station provides the image plane, or a return for their antennas if they are indeed vertical, single-ended antennas, if you will. I clean out the ground idea for RF and use return. RF fields need a return, and that doesn't have to be the Earth. Just a minor irritation on my part based on pretty basic electromagnetic theory. W0LEV, and I need to go to the kitchen.
You should have brought your dinner to the desk like I did. Anyway, thank you, Dave. Yeah, and I know that term has caught us all off guard because that seems to, ground seems to appear all the time and seems to be very deceptive in what is actually really needed there. Okay, N7GES. Have we brought any other questions up to anybody's minds on, not on necessarily just this topic, but anything else dealing with radio, antennas, repeaters, etiquette, anything else here at this point?
MIC.
MIC, go ahead, Mark.
W2MIC. Oh, I would like to continue the counterpoise versus radial question you asked initially. I'm thinking here of some great YouTube videos from the United Kingdom where a chap takes a great big long seaside telescoping fiberglass fishing pole down the beach and hauls up a wire 17 feet long, which for those of you who are math challenged like me, that is a quarter wave on 20 meters. And he then puts out a second piece of wire running along the sawgrass on the beach, and that is his counterpoise. So as Dave, W0LEV, was saying earlier, when you start with the model of an antenna, think of a half-wave dipole, a quarter wave on one side fed from the coax center, and a quarter wave on the other side fed or connected to the shield. I'm going to drop and come back up here. Now, you can run that half-wave dipole horizontally, or you can support it in the middle in what is called an inverted V, or you can turn the whole thing vertical. Or, better still, you can fold it 90 degrees and run the vertical section driven from the coax center, straight up and down, and you can run the other half of the dipole out horizontally along the ground. That is a counterpoise. That is the matching network as a piece of wire for the vertical section. You can add, and you need at least one counterpoise for matching. The problem with a single counterpoise is that, as Dave was saying earlier, you have a return path, so that vertical is radiating energy, and a great deal of the energy is getting down into the dirt. Notice I'm avoiding the use of the term ground. So if you build a vertical antenna and pound a stake into the dirt, the signal will in fact come back through the dirt to the ground rod and back down the coax. Again, I'll drop and come back up. Signals traveling through the dirt encounter a lot of loss. Dirt is not terribly conductive. What you really wish you could do is to shield the dirt from the antenna by putting up a large sheet of copper several miles in diameter so that no signal would get into the dirt. All of the signal would come back via the highly conductive copper image plane, sometimes called a, heaven help us, ground plane. And the idea there is that you are trying to have the return signal not be lossy by traveling through the dirt. Well, obviously, a sheet of copper several miles in diameter is impractical, both physically and financially. So what you use instead is some collection of wires of the correct length to be a counterpoise. And to radiate with a little bit of efficiency, you want 3 or 4. If you are a commercial broadcast station like KLOV or some big AM or FM tower, you want nearly 100, probably more. 256 would be great. And what you're doing is putting down a radiating set of wires trying to imitate that high conductivity ground plane. Again, I will drop and come back up. As Dave was saying, and as Greg was saying, if you put a quarter wave vertical on top of a metal vehicle, like a sedan, a Chevy Suburban in my case, an ambulance in PRB's case, you have a big sheet of metal, and for short wavelengths, that's sufficient, like 70 centimeter, 2 meter, 6 meter, maybe 10 meter, probably not. If you are trying to get along with the minimum amount of wire, 3 counterpoises, probably 4 is better. But in doing a small number of counterpoises, you're still running a lot of signal through the dirt, and you're giving up a lot of energy. So your effective radiated power is still very low. When you get a half-wave dipole up in the air, your effective radiated power is pretty near perfect. So really what we're talking here with counterpoises is matching, and with radials is shielding the Earth and upping your radiation efficiency. Okay, that was a very long rant. Back to you, Kevin.
0 WIQ, isn't that to them?
Yeah, I appreciate that, Mark, actually. That was quite nicely simplified for my brain, anyway. Terry, go ahead.
Another aspect is if the radio is a quarter wavelength long, it will show a short at the end rather than and therefore not lose anything to the ground. So you might keep that in mind also. If you want to be limited to one frequency that you can have a quarter wavelength ground plane for. Back to net.
Okay, any other discussion here or questions that this brings up?
EMP.
Hey. We had 2. I only caught 1. EMP, let's go first.
Yeah, to add on to what Mark described there, folks will build a vertical antenna that's based off of the ground, and when I say ground here, I mean the surface of the Earth. It's a pole sticking up out of the dirt, and that's the driven element. And then they'll run these radial wires out, and if the radials are on the dirt or just buried slightly under the dirt so that you can mow your grass that's growing out of the dirt, you need a lot of radials to be efficient, because like Mark said, you're trying to shield the dirt from that RF so you don't have the dirt loss, because it's not a good conductor. If you get your radials up off the surface of the dirt, even a few feet, that helps a lot. A lot of folks will go 8 feet above the dirt so that someone can't come along and touch the radials and get an RF burn. But for a field thing, for setting stuff up, portable, semi-portable, backpack, 3 feet helps a lot. And if you get 3 feet off the ground and you only have 4 quarter wave radials, it actually works really good. And 0 EMP.
K0EV.
Hi there, Eric. Go ahead.
Yeah, I was just going to give a testimonial, really. When I lived in Loveland, I had the fortunate to have a tower up, and I used the vertical wire element about 66 feet, and then a quarter wave, of course, another 66 feet off to the side, at about 10 feet high, well, about more like 8 or 9 feet high. Worked great on 80 meters. Fantastic antenna. I also put out a bunch of radials. Before I had to move, I think I had a bit over 30 of them out there. Not a lot, but they were all 130 feet long. And since I had aluminum up on the top of the tower, I managed to, it was top loaded, so I could work 160 with that thing. Didn't take much of a matching network to load it up on 160, but I know I was losing a lot of it in the ground, and that's why it was easy to match, because I probably had, I don't know, 10, 15, 20 ohms of ground loss.
Okay, did we miss somebody else in the list here? Well, this has been real informative for me because, and I know I studied this information and took the test and things like that, but unless you continue to study it or use it or fiddle with it all the time, it's hard to remember it always. But the kind of confusion over what the ground does for you or doesn't do for you, I'm talking the dirt ground, does for you or doesn't do for you in various situations, and that's that's been informative here this evening to get a little more clarification on that one. This is N7GES with the TechNet. Anybody else have comments either on this subject or others?
KB0SCX, George and Berthoud.
Good evening, George. Good to hear you. How are you doing?
I'm doing fine, thanks. I did have a question about the artificial ground. When you're using it, do you have to tune it for the specific frequency you're talking about, or is it a universal artificial ground?
Anybody used one of those things that can give us any kind of info? It doesn't look like we've had much use of those, so we don't have much info on that one, I guess, George. Sounds like one of these things that is not in wide use and maybe not a very effective thing to use, so I don't think many of us have much info about it.
Well, thank you very much. I was just curious. Hard to see how they would work. This is KB0SCX.
Yeah, K0EV again.
Yeah, go ahead, Eric.
Yeah, I can't really elucidate on artificial ground, but it does have knobs, so that might tell you something. The other thing is, I use a choke balloon, a choke, either a coil of wire or a bunch of ferrite or a commercial choke in the coax to keep RF out of the shack, and that's especially useful on an off-center fed dipole, which Greg EMP was talking about. And yeah, I love those things. They're just awful dang sensitive and tricky to tune up. K0EV. For multi-bands.
Okay, very good. Well, cool. Good info, and as I say, I appreciate the explanations. Anybody else have questions or topics they'd like to ask about?
KG0HM. I once put up a loop antenna on my roof. I got great reports. The only problem I had was I got it on my phone.
Okay. What bands was this for?
It was all bands. It was long, very long. Covered my whole roof on, and I just laid it out. But I don't know who else got RF into it, but I couldn't use it anymore.
Greg, do you use your loop antennas for transmission or just receive at this time? Must have lost him. I know people do use loops fairly successfully, but I know they have their tricky spots. I don't know if anybody is around that can elaborate any more on those or not.
Yeah, doing that several years ago, and they were amazed how I was getting in there, and they were suggesting somebody else could get one, but if I'm getting radiation into my phones and all that, I don't know who else around the town got it too.
EMP. TV again. Horizontal loops are great.
Okay. I take it you haven't had much trouble with RFI with yours, huh?
Oh yeah, well this was a long time ago, far away, where I actually had trees, and so I put, it was just an 80-meter one, 260-some feet of wire, up in the top of the trees, 45, 50 feet up there. Worked real well, especially loud, local stuff, United States, not DX. Yeah, I got into the phones because by that time we were buying all these transistorized pieces of junk, and those things just like to suck up RF. And the only way to cure that was to either unplug them or stick RF chokes in the lines because, phone wire is a great antenna. It's not shielded and it's random lengths, and who knows when you're going to pump, most a lot of your RF into it. So back when we had the old Ma Bell phones, it was tough to get into those. You could, but it was tough. K0EV.
Okay. You did have EMP. Go ahead, Greg.
Yeah, I've got a 80-meter horizontal loop. That's my primary transmitting antenna now and receiving antenna for HF. If you make a loop antenna that is one wavelength in circumference at some band, it will tune up there and every band that's higher frequency than that. It won't tune below it too much. Like my 80-meter loop, I cannot tune it on 160, but it'll tune everything from 80, 40, 20, 10, all the odd bands in between. My loop is off to the side of my house, so I don't have too much trouble with RF getting in. The other guy, I think he said he had a loop around his roof, around the perimeter of his roof, which is one way to do a stealth antenna, or get an HF antenna if you don't have a lot of room. But if you do that, your entire house is inside of your antenna, and you will get RF. And it's not an issue of mismatch or not having radials or counterpoises or an image plane. Your house is inside your antenna, and you will saturate everything with RF if you do that. And 0 EMP. Okay, well, there you go, Lud. I guess you
And I don't know if you were, I don't know when this was, or if you were having trouble with mobile phones, or if this was later when it was well, of course, a lot of our later landline phones were all transistorized things too, so that would have been fairly easy to get into as well, I would imagine.
Yeah, it was portable phones. Yeah, I thought about putting the antenna on the fence and everything like that, but that wasn't going to work out with somebody.
Yeah, there's always a limitation. Anyway, okay. Well, that's interesting as well, and loop antennas are something I don't know a lot about except for what we're getting here this evening, but they sound fascinating. So it's good to hear the info about them. N7GES, this is the TechNet. Anybody else have anything?
This is
KD0ZWU. I have a comment on loop antennas.
Okay. We had two people there. Let me take ZWU. Good evening, sir.
Hey, Kevin in the net, KD0ZWU. I use loop antennas for receiving purposes, but my loop antennas are vertically oriented, not horizontal, and they are very small compared to a fraction of a wavelength. And they have a very good advantage that they actually like being close to the ground. As Dave LEV pointed out, Mr. Maxwell's equation says that the electric field goes to zero at a conducting surface, but the magnetic field doubles. So a loop antenna is a magnetic field antenna, and it loves to be next to a conducting surface, be that dirt or a piece of metal or whatever. And that's very handy. Their difficulty, of course, is that they are highly inductive, and they need a capacitor to tune them if you want to transmit with them. And their bandwidth is very narrow, and their Q is very high, and that leads to perhaps dangerously high voltages. So you can use a vertical small loop antenna for transmission. It takes a lot of engineering to make that work properly. But for receive purposes, they work great. KD0ZWU, back to net.
Okay, very good. And I think WIQ had a comment as well. Go ahead.
Okay, Kevin. My comment is that a couple of years ago, Radio Dan, put up a horizontal loop on some telephone poles, and he bragged about it being like having a beam in every direction. Although I think he had a square loop, so it would be in 4 directions, but anyway. The ideal for a horizontal loop would be to hang it up in a circle, so it would work equally well in all directions. But anyway, that's what his comment was. You have the side that's being driven, and the side opposite is the reflector, so you have a beam out of a loop. So anyway, that's my comment. Back to net.
Yeah, I think he still has that antenna up and is still using it, perhaps. I know I've heard a little bit about that in the past as well, so, yeah. As long as you've got plenty of energy and time to keep the poles and everything maintained and stuff like that, and if you have the property for it. So, yeah, good stuff there. All right, this is N7GES. We're still doing technical issues. We don't have to stay on antennas or loops. We can certainly diversify if anybody has any other questions they'd like to cover. Happy to do it.
ZWU with a comment?
Go ahead, Terry.
I know Kerry knows this. I'm just going to remind him a bit that usually when you're talking about a beam and HF work, you're talking about an antenna having gain or directivity in a particular direction. And the phrase, a beam in all directions, is an oxymoron.
Okay, you'll have to fill me in on this one, I guess. I'm sorry, but I haven't quite gotten that far along on this.
Okay, I would be glad to elaborate. Antenna gain, when you want to increase the gain of an antenna in a particular direction, you concentrate the energy in that direction as opposed to radiating it omnidirectionally. So that's called directivity. Gain and directivity are synonymous, plus or minus antenna loss, which is usually small. But so when you have a beam antenna, what you're doing is you're focusing the energy in a particular direction. This is why you have to spin them in order to point them in the direction you want them to transmit or receive. So you're focusing the energy in one direction as opposed and not having energy in any other direction. So a beam in all directions is I can't make sense of that. You're talking about the difference between a beam antenna versus an omnidirectional antenna.
Yeah, okay. I get you now. It's pretty basic when you come down to it that way. Alrighty. We had a huge double, and Terry, you did win that. Who was the other station there?
0 WIQ.
Okay, so you did not hear all of Terry's comment, and essentially beaming in one direction is possible, but beaming in all directions may not be. Sort of was the boiling down the comment, and I know that you are aware that we're talking about acts like or does like or that sort of thing. So I don't know if that's what you were responding to or not, but just to fill you in a little on Terry's comment. Go ahead.
So it's one of those things. Antenna conversations come up among amateur radio operators a lot because a lot of them don't know as much as Dave W0LEV knows. And I don't know as much as he knows, but a man-made antenna is a compromise in the first place. Then you choose the compromise that works for your particular situation. And that will work, or that train of thought will work for any antenna anywhere in the world. But you have to know enough about the situation and the antenna of yourself to have any idea how to make one work in any place in the world. It's just that everyone is a compromise. You pick the compromise that works for you.
Yep, that was bringing to my mind we measure dB over either a dipole or the dBi, and I can't say the name of it again tonight. I am definitely not the one to come up with answers on this TechNet tonight, because every single name I try to come up with is gone from me. But anyway, that wonderful ideal antenna that we can't physically achieve, so we compromise it. Somebody will have to fill me in on that term again, because I have lost it.
Isotropic.
Thank you very much. Isotropic antenna. Yes, the one that we'd all like to have if we ever could.
KD0ZWU.
Go ahead, Terry.
Much like the term ground is widely misused and widely misunderstood in amateur radio, the term gain is probably also equally widely misunderstood. A better term is the term directivity. And again, these two terms are related in antenna theory. And directivity gives you the sense that you are taking the energy from one direction and putting it into another. The term gain somehow has a misconception that you're somehow adding energy to the situation. But as Carrie said, and that when you're compromising, you're making your antenna design, you're making compromises. And directivity is saying that you're putting energy in one direction in favor of not putting it in another direction.
0WIQ with a comment about directional antennas.
Okay, go ahead, Terry. Carrie.
One spec that's not mentioned very often is a directional antenna has a front-to-back difference. So they will transmit off the back, but it's not as efficient as transmitting on the front of a directional antenna. So that's the main thing. And the front-to-back gain or difference can be stated as a gain factor, but on the other hand, it's not really a gain, it's a ratio. So I'll just put that out there. This is N0WIQ.
So, Terry, I guess if I'm understanding you correctly then, my little arrow J-pole up on the roof here, which is said to have essentially no gain, is just not favoring energy in a particular direction. Then is that? But my collinear UVS 200 up here is focusing energy. What would I say? Vertically? Specifically? Rather than just any direction?
Kevin, I don't know the model numbers that you're talking about. The latter one you mentioned, is this a vertical, like stacked antenna?
Yeah, I think it would be. It's a collinear. It's like all of the Diamond X50, X200 type antennas. So there's several elements inside that tube there.
Well, understood. And for a vertical antenna on UHF and VHF frequencies, that's kind of what you want. What that is doing is the extended element in the vertical direction is focusing, i.e. producing antenna gain toward the horizon, and it is taking it away from radiation in the vertical direction where you don't want it in that particular application.
Okay. Well, thank you. I appreciate that bit of clarity as well. Any other comments on this, on any of these things? Okay. Any other questions from anybody about any particular radio topic? We do not chastise anybody for moving to a very, very basic operational question or anything of that nature here either. But we're trying to make room for any question you have.
Oh, Kevin, I would suggest that people look into the idea of chasing RFI because it can happen anywhere. For me, it just happened on my local area network. So I noticed it because I was replacing Cat 5 with Cat 6 shielded cable. And I noticed it because some things stopped working because of the RFI. So that's my story. Back to net.
Yeah, you've definitely had your hands full of that here these last couple of weeks, haven't you? Yeah, and that was a sudden change, I take it. Do you have any idea what made that change, or had you just not noticed it prior to that?
A internet or networking cable is nothing but a bunch of wires carrying electronic current. Electronic current makes magnetic fields. So, I mean, this is real basic. So, if you have a Cat 5, which has got little insulated wires, not shielded wires, little insulated wires in the cable, each one of those wires makes an antenna for the digital signals that are passing. And the digital signals are quite a wide range of frequencies going through them. So they're not really a tuned antenna, but they are a radiating element. So what can I say?
Exactly. Well, and then the other thing to know when that sort of thing happens is, have you had trouble all along, or has something suddenly changed that started to cause you to realize you have to suddenly replace all your cabling? There's the diagnosing of things can be a little tricky sometimes. In my situation, when I started out, I had all kinds of trouble when I ran the station on HF with the internet, and when we stabilized the open and non-properly terminated connections in the attic, that ceased. That took care of it. So I went from having problems to never having any issues anymore. But certainly to go the other way, then that creates another whole set of situations that you have to try to trace down and face down. So, yeah, good luck to anybody that's having to deal with that, and go through it in a careful process. What did you add? What's causing problems? What is it causing problems with? And then slowly be able to trace it down to where it's number one coming from and what it's going into, and you might have to do work on both ends of that picture.
So it's like this: any conductor that's carrying current will emit a magnetic field. Now, if that magnetic field or that current is an alternating current, then it will generate an alternating magnetic field. And this is how an antenna works, is we have an alternating current activating a conductor, or going into a conductor, and the current needs a complete circuit, so what goes in has to come back somehow. So that's the kink in an antenna. And then you tune this antenna to a specific wavelength, and lo and behold, it does a magical thing called resonating. And so it works, everything works optimally from the output amplifier to the antenna, and the antenna to the air. So, hey, this is all less mysterious than a lot of people think. But on the other hand, it's all based on the idea that a current through a conductor generates a magnetic field.
Exactly. Okay, N7GES. Anybody else want to add anything or ask a question here? Not wanting to leave anybody out.
Yeah, K0EV again.
Okay.
Yeah, let's go back to telephone wire and then LAN wire and the various Cat 3, 5, 6, 7, etc. Yeah, it's twisted pair, and twisted pair, you know, has a characteristic impedance and it's balanced. And if you terminate it, which I understand, probably what you did, Kevin, when you got rid of all the open stuff up in your attic, you terminated the stuff, you know, it's going to stop picking up what's called common mode, which is down along both wires instead of, you know, unbalanced, in other words. But the twisted pair is essentially balanced, but it's not perfect, of course not. It's but hams way back when used to use twisted pair. They used ladder line, and then they also used twisted pair to carry RF. Well, anyway, enough of that. Shielding with the new stuff, like DDZ was talking about the other day on Cat 7, is so much better. And we all know why, because we've been using coax for years.
Zero WIQ again. The Cat 7 cables use shielded twisted pairs in one cable that is probably shielded also. And twisted pair is only good for about 30 or 40 dB of isolation as far as interference is concerned. And it works because you have the two wires both being interfered with by the same signal. And so they reject the interference and the signal goes through and is copyable at the other end. So, hey, this is the whole thing about twisted pairs and common mode rejection in a nutshell. So, like I said, the Cat 7 has something like 4 twisted pairs in shields each, and then another shield outside of that to boot. So the twisted pairs, 30 or 40 dB, the shields another 15 or 20 dB, and another shield. I mean, hey, it all works out that way.
You got that right, Kerry. And yeah, you probably have to pump lots of kilowatts right next to it to get into that kind of cable. Yeah, it really sounds like it's going to do the job. So, and the other thing is, hopefully all that RF, which those digital signals are lots of square waves, and they generate all kinds of interference. Hopefully that Cat 7 will keep that stuff out of our receivers. K0EV.
Yeah, that's something I had to do with all these darn TV boxes and stuff that we've got around, because they're certainly generating a fair amount of noise upstairs. But, well, yeah, time for another project for another time. Yeah, thanks for the good info on that, and we're certainly surrounded by it, so we might as well do the best we can to make it work well and keep it out of keep our stuff out of the digital realm and the digital realm out of the RF realm as much as possible. Okay, any other comments of any kind? Simple or complex? Any questions before we quit here?
Well, Kevin, I'll say one thing again. These little radios that we buy from Yaesu and Kenwood and all that give us affordable radios are nothing but a compromise inside. It's almost a wonder that they work as well as they do, but that's my view. I've worked with transmitters and receivers that were high-end versions of our amateur radio stuff, and keeping the RF going in one place rather than all over inside the radio is a real chore. So back to net.
ZWU comment?
Go ahead.
Yeah, it's interesting, this conversation about Ethernet cables in particular and shielded ones, because there's a bit of a trade-off here, because what you are trying to do is keep the harmonics of the Ethernet signals from radiating, and a shielded cable does that very well. The other side of the coin is that you're going to plug this shielded Ethernet cable into a hub, and the hub is going to have a 99-cent, very cheap power transformer, wall wart, that is going to power it. And what's going to happen is that the electromagnetic energy and electromagnetic interference at RF frequencies generated by that power hub, by that wall wart, is going to get onto the shield of the Ethernet cable, and is going to run on the outside of the shield of that Ethernet cable, and it's going to make a very, very nice antenna. And this is the cause of a lot of RF interference from the Ethernet devices to your radios. So a good shielded cable will prevent your radio from affecting the Ethernet, but if your power supply is generating a lot of RF noise, it's going to radiate on the shield of that cable. KD0ZWU, back to net.
And for any of you who are new here, I know if you're new to radio in general, it may be that some of this stuff sounds very, very over the head and stuff. But believe me, it's not as complex as we're making it sound. As far as what's going on, you know that we all know that now that we've been into it for a while, that most of our little electric plugs that power something are big noise generators. And it's very, very hard to get away from those, because that's primarily what's available when you buy any kind of an appliance that's got a little plug. Chances are it's a very noisy little power supply, and that noise is easily radiated into all kinds of things. So that has been an issue we've talked about numerous times, and you'll hear about it numerous times, and what a person has to go to try to eliminate some of that. Sometimes there's not a lot that you can do except to try to replace it with something else that's not as noisy, which is not necessarily an easy thing to do, especially if you're dealing with lots of different voltages and stuff. Anyway, you'll hear this topic discussed again and again because it is a prevalent problem. Don't be afraid of it. Just be ready to realize that when you run across something that's making your HT go crazy in your house, that's what we're talking about. And at some point, it may cause you not to be able to receive a certain frequency that you were wanting to receive. And there are steps people can take to keep that signal down. Ferrite cores help. Better cables, further separation from equipment. Lots of little things, but totally getting rid of that noise without using something different to power that equipment, or different to house that equipment, or different ways of keeping that equipment isolated is always going to be a bit of an issue. So you will hear that topic again, and don't hesitate to ask about it, because specific situations we can certainly easily talk more specifically, perhaps, to give you suggestions and information there. So just a little editorial comment for any of you who have not heard about this before. It will come back. Don't worry that you have to understand it all in one sitting, but be ready to run into the situations and ask questions and figure out what we can do to help you and everybody else around us out with our noisy little equipment stuff here. This is N7GES. Anybody else?
K0PRB with a question.
All right, go right ahead, Phil.
Well, when it comes to radials, I know that you have to be careful with the counterpoise or radials. When transmitting, if you touch them, they're bare wire. If they are bare wire, not all are, you can get RF burns. So you have to be careful with those. So when it comes to a vehicle, your vehicle is the one half of the antenna, per se. So if you transmit and touch the vehicle at the same time, will you receive RF burns?
Probably not. This is N0WIQ, and I say probably.
That's a good question. Would anybody like to maybe give a theory as to why that doesn't necessarily happen? Certainly touching the antenna will get, you'll probably feel it, but certainly touching just the outside of the car, I don't believe is usually a problem. Anybody want to hazard some knowledge in that direction?
MIC.
MIC, go.
Sure. Phil, first, are you standing on the ground in your bare feet touching the outside of the vehicle, or are you inside the vehicle touching the metal framework of the vehicle?
Well, and that raises a very good question. What if I'm outside the vehicle, barefoot, and touching the vehicle?
Well, if you're running a wire antenna, specifically a half-wave dipole, you get very high voltages at the ends of the wires because there is no wire for the electrons to flow down. At the feed point to the antenna, you get very high current. So you can get a nasty RF burn hanging onto the end of a quarter wave wire segment. But in your vehicle, you have, because it's all connected, you have all many different lengths. You have quarter waves and eighth waves and 5/8 waves and 17/19 waves and everything you can think of. And as a result, you can't find one point on the vehicle that is equivalent to that quarter wave dipole. It's connected to everything else all around. And no, you effectively don't get any voltage at all.
That was the answer I think I was looking for. Yep, because I wondered the very same thing. Because the car is actually a part of the antenna, namely because it's part of the shield. You know, it's connected to the shield of the coax if set up properly. So yeah, it was like, okay, well, if you've got power, so there is power on the external portion of the vehicle, but you won't necessarily feel it. Am I correct there?
You are correct.
Okay, thank you, Mark. Thank you. Back to the net.
ZWU with a comment or question?
Go ahead, Terry.
For Mark and Phil, the way I visualize this is that since your vehicle is the counterpoise for the RF, the RF is going to flow through the metal of the vehicle and back into the shield of the coax cable that is driving the antenna. And for you to get any kind of energy off of that when you touch it, you and your bare feet down to the dirt have to have a lower conductivity than the skin of the vehicle. Is that a correct way of looking at this?
I agree.
Yeah, the conductivity, the resistivity of your skin is about 250 k ohms. The resistivity of the vehicle is down in the tiny fractions of an ohm, depending on how well the welds are done. So preferentially, the energy being radiated out of the driven element goes out and comes back to the sheet metal and flows through the sheet metal. And if you count watts per square centimeter or watts per square inch, it's a very low energy density to begin with because that's a great big surface. And then it's all going to go back to the base of the antenna and into the shield, and that's a higher conductivity path than through you, the human, to the ground. Now, if you're doused wet and it's raining, same comment applies. It's still going to have a higher conductivity path through the metal than through your wet finger, your wet skin, and your wet feet. So you're in good shape.
And by that time,
compare this to the situation where you have an elevated radial. That radial does not have a return path, and so there will be high voltages on that elevated ground radio, elevated radial counterpoise, and therefore you might be the lowest resistance path from that for that current into the wet grass.
Terry, come back with that one more time. Just because I need the clarification on the difference.
Well, I think Phil had mentioned the comparison between the vehicle condition and compared to when you have a vertical antenna with elevated radials. And I believe those elevated radials do have high RF voltages on them, and they are intentionally not connected to the dirt. And therefore, if you touch one of them, you might be the low impedance path for that RF energy from that radial through your body and into the wet grass where your feet are sitting.
Yes, the voltages on those radials can be in the kilovolts.
I guess that's why many people choose to keep them 6 or 7 feet above ground to eliminate the possibility of accidental contact.
Yeah, and it's fun to walk along
light bulb too.
N0WIQ with an additional comment. If I was going to put radios skybound, I would put them at least 12 feet in the air, because then you have less of a chance of a person coming along and touching them and having an issue with them. So, hey, that's my rule of thumb. So, that's what I have learned over the years, is a lot of rules of thumb.
Okay. All righty. It's good to know fluorescent bulbs are good for something there. All righty. Anything else from anybody? We could go on like this all evening, I'm sure, but I could turn this over to the postgraduate net here before long, I think. Does anybody have any more questions that we can answer before we perhaps turn this into open, informal discussion here? All righty. I think we had a good discussion here and covered a lot of things. I hope we were of some help to others. This was certainly a good bit of knowledge for me, and I took a bunch of notes. We had 18 check-ins tonight, and we've been running since 6. We're at 1946 now, so we've been on the air a good hour and 45 minutes. So thank you again, 73. If you have topics you'd like to discuss, let me know. If you have specific questions you'd like to ask and you don't want to wait till net time, put them up on Elmer at NCARC.net. If you're a listener only and you're not licensed yet and you'd like to ask questions, that's probably a way you could do that as well. And then we can try to cover some of these questions on TechNet. If you want to write to Elmer with those comments and just mention TechNet in the email, so that we know that you might just want to hear some discussion or something, we can take advantage of that. Thank you all again very much for being here. Thanks for the lively discussion and for being a part of helping everybody else that's in the ham radio hobby. This is N7GES. We'll close the net and return the frequency to normal postgraduate or undergrad use, whoever chooses the frequency. Thanks again, and 73 is all from N7GES.
M7GES, I was wanting you to add me to the check-in, KE0MQA.
I can do that. Good evening, JR.
Yeah, good evening. And I did like the example of the vehicle. That was a good one. I knew for a fact that you couldn't get zapped from it, but just from practical experience. But I suspected it was the size and the mass, and that pretty much clarified it for me. So anyways, very good. I just got the last part of it, but very good discussion.
Well, you're welcome. You're welcome, JR. We brought up some of the discussion that you've had with Greg to differentiate terms like ground plane, counterpoise, radials, and all that sort of stuff. And that's kind of where all of this eventually came from. So there you go. You provided some good discussion fodder there.
Well, I wish I would have checked in earlier. I went over to the traffic net. I was wanting to hear some more traffic over there, and then when that was done, I came over here. So with that, I am going to call it a night. So anyways, good day and good evening, everybody. K0MQA.
Well, you have a pleasant evening and enjoy it, and we'll talk to you later. I'm going to hit the sack shortly, too. I have a very, very full day in Denver tomorrow, so I don't know how...